In 2009, deep in a Colombian coal mine, scientists found bones that shouldn't exist. Bones so massive they had to recalculate 3 times because the numbers seemed impossible. They belonged to the largest snake that ever lived, a 50-foot snake that weighed over a ton. And here's the thing, some researchers think it might not be as extinct as we believe. According to textbooks, Titanoboa vanished when Earth cooled. It was cold-blooded. It couldn't regulate its own body temperature. And when you're a snake the size of a bus, even a small drop in heat is fatal. During the Paleocene epoch, the planet was brutally hot, around 90 degrees Fahrenheit year-round, with no winters. Perfect conditions for a massive ambush predator. Then temperatures dropped. Rainforests shrank. Giant prey animals disappeared. Titanoboa couldn't hunt efficiently, couldn't digest fast enough, and slowly starved. End of story. Extinct. Gone forever. Except, that explanation has problems. In 2018, scientists discovered fossils of a prehistoric snake nearly 35 feet long, 11 million years after Titanoboa was supposedly wiped out by cooling temperatures. That raised a very uncomfortable question. If the planet was too cool for Titanoboa, how was a snake almost that large still surviving? When researchers re-examined climate data, they found something else. Earth didn't cool smoothly. There were multiple warming spikes, brief periods, where parts of the planet returned to near Paleocene conditions. Not everywhere, but in isolated tropical zones. The Amazon basin, Central Africa, Southeast Asia, and those regions were barely studied. Modern evidence adds another layer of doubt. Anacondas and reticulated pythons today are reaching 25 to 30 feet in environments we once thought were too cool to support giants. So, what happens if temperatures rise just a few degrees more? Up to this point, none of this means Titanoboa survived. But what scientists noticed next completely changed the question. During a reanalysis of the Eocene thermal maximum, researchers found that for roughly 200,000 years, parts of South America were almost identical to Titanoboa's ancient world. Hot, humid, stable, and right during that window, there's a massive gap in the snake fossil record. Not because snakes vanished, but because rainforests destroy fossils. Acidic soil, moisture, and biological activity dissolve bones before they can fossilize. So if large snakes survived in those environments, they would leave almost no trace, which means something unsettling. The absence of fossils doesn't prove extinction. It may simply mean the environment erased the evidence. Recent satellite studies add to the mystery. Thermal imaging has identified remote Amazon river systems with year-round water temperatures above 88 degrees Fahrenheit, hot enough to theoretically support far larger reptiles than any officially recorded today. These areas are vast, inaccessible, and almost completely unsurveyed. So, let's assume a descendant survived. Not a 50-foot Titanoboa, but something in the 35 to 40-foot range, isolated in pockets where conditions never really changed. That would rewrite how we understand extinction. It would mean extinction isn't always final. Sometimes species shrink. Sometimes they retreat. Sometimes they survive quietly, waiting for conditions to swing back in their favor. And that's where things get disturbing. Because climate change is recreating Titanoboa's world. Tropical temperatures are rising. Warm river systems are expanding. Wetlands are returning. If large, cold-blooded predators still exist in isolation, we're not just preserving them, we're expanding their habitat. We may be rebuilding the exact conditions that once allowed the largest snake in history to dominate entire ecosystems.